Here's a mechanical system I made just for fun. This system consists of it's driven by a gas cylinder, which is basically a cylinder filled with a gas that alternately heats and cools. When it's hottest, it's red. When it's coldest, it's blue. The degree of transparency shows the pressure. When it's very transparent, the gas is rarefied. And when it's dark, that means that the gas is compressed. The piston is represented by a slider, which is a mass that can only move horizontally. The other end of the gas cylinder has to be told something about how to move, and that's done with an anchor, which is basically a mass that can't move at all. That's the way to think about that. The suspended from the slider is a double pendulum, which is two weights, each dangling from a rigid rod in succession. And you can see from tracks that the masses leave behind that they follow complicated patterns. We can then just start to change the system kind of at random. Let's go to design mode and then like delete one of these push rods and then see how the system behaves. I'll have to zoom out, but you can see the part that I cut off just drops under gravity and is gone. That's what you should see if you do that. Go back to the starting view, and I'll just reparse the model from it to its original state so that we've got our original system together again. We can do other things. Each component in the model has connectors on it. So a spring, let's create a new spring. A spring has two connectors, one at each end. This is the new spring here. And I can move those connectors around. I can also connect them to something else. So let's try connecting a spring maybe at one end to this weight and at the other end to the slider. And we'll make this initially just a weak spring. So the spring constant of this spring, we can look at its component properties. The spring constant of that spring is just 1 Newton per meter. That's a weak spring, especially compared to these rigid rods. So we'll see it affect the behavior of the system, but not drastically, I guess. You can see that the system now, the pendulum now prefers to be kind of bent at the elbow here, which is a little bit different from before. If I harden up that spring a little, we'll see different behavior. Let's make K 1000 so that it's almost rigid. And we'll make its rest length of that spring 1.41, which is just the length in the mechanical drawing here of its starting, just the starting length of that spring. So that means it'll actually want to stay the same length all along unless something works hard to deform it from both ends. And you can see that now we have really something close to a rigid triangle. I could have made the spring even tighter. We have something close to a rigid triangular part dangling as a pendulum. Except that it's shaking around like crazy. So not quite rigid, but pretty rigid triangle. You can make them more rigid, or use a perfectly rigid part. And then again, if I let's say delete the gas cylinder at this point, now the slider isn't getting any horizontal force on its connector. So the internal math of the slider is only seeing horizontal forces from the two masses that are dangling beneath it. And the slider has friction and is going to grind to a halt here without any driving force on it. And so that system just runs down to a stop. We can do all different things. If I delete this one now, the system should unfold vertically. And there's still, as long as the system, as long as the masses are jerking sideways, there's a little bit of horizontal force on the slider. But every bit we move the slider, it drains away our energy, and gradually the whole system is just going to come to a stop in a vertical line. Each model only sees things that come in through its connector. So they don't even know the anchor is there anymore. It's not connected to anything. And again, if we cut the stuff that holds something up, then it won't stay up. So the two masses that we've isolated from the rest of the system will drop off, and presumably their altitude will go parabolically with time, because that's how gravity is supposed to work. Let's plot that and take a look. Fit our plot window into the screen here, and plot weight 1's altitude and weight 2's altitude. So here we go. We've got a plot that shows a parabola over time. All right, that's it.